And here's your trusted advisor. Let's talk about Spark job definitions. You have great code, you have everything in a notebook, you need to schedule that to run every morning at 3 a.m. And you have the next notebook at the next one, and you realize, okay, so the notebook is not really production ready code. We have interactive parts in there, we have data exploration parts in there. I need a proper monitoring. This is the time for Spark job definitions. Let's start with having a look at the Microsoft Fabric periodic table. We have the Spark job definitions, of course, in the periodic table. So let's jump in. You have a proper description, you have some usage scenarios, you have technical background with the naming convention, the CLI references, and so on. That's really a good start point when you want to get an overview about all these different Fabric artifacts, in this case, the Spark job definitions. When we jump into the theory, you start, because, well, it's all Python, right? You start with development. Development, which in this case means you write Python code, or you don't even write the Python code. You use maybe a large language model to get that code. Either way, you will end up with a notebook. And with a notebook, you will have something like an interactive experience. The interactive experience is like, well, test and iterate. And of course, this goes round and round because you optimize your code and you're getting better and better. So this is part of the development experience. And there you create your working notebook. At some point, let's say, okay, this is now production ready. Let's jump over and let's promote that. Promote. Let's promote that to a Spark job definition, which means to production. So now we are in production. And you will take your notebook and create a Spark job definitions out of that. So, the Spark job definition is your code, additional parameters, additional files that you might need, and a schedule. So the next thing that you want to do is you want to create a schedule. And the result is you will get an automated run. This is nothing that you could not do with the existing notebooks, of course. But the main benefit is that you can work with two different kinds of code. The notebook experience is interactive. You have outputs where you can check data, cross-check data, understand errors or issues or something like that. While the production-ready code don't need that, might need much more logging, might need much more reporting to a central, I don't know, monitoring instance, all that stuff that you don't need in your notebook. In my experience, it's even more worthy to have completely separated code trunks that do some kind of cherry picking of features, because you don't want to see your development runs in your production monitoring systems. So the result is that you have your data updated at some point, let's say at 3 a.m. 3 a.m. in the morning. So this is then the production scheduled run. So you have two parts here, right? You have the development part, which is separated from your production part. And this is separated by not only by different areas, but it's separated by completely different toolsets. In the development area, you use the notebook and you have all the interactive experiences. And in production, you use your Spark job definitions and you have all the monitoring dashboards that you need and all the professional stuff. Separate concerns, more or less same code. There might be differences, but today in the age of large language models, I think it's pretty easy to use a model to make the production switch and then of course check it. It's your responsibility in the end, but you don't need to write all the code on yourself anymore. Let's decompose it a little bit, the idea of Spark job definitions. So what's inside of a Spark job definition? So let's draw it. It's always so helpful. So this is a Spark job definition. Let's make a decomposition. So first and foremost, you have your main definition file. The main definition file is nothing else than your code. This is a .py script. You can add additional references. So for example, you can reference to your notebook. If you want, or to additional code, that makes absolutely sense. But the main part is that you have your main Python script, like the entry point. The second thing that you most probably will need are parameters. Parameters make your script more flexible. You have more reuse. You can run it on different times with different focus areas. You can provide args. Like on the command line. And you can provide Spark configurations to align the used Spark environment exactly to your needs. So this gives you flexibility, so you can reuse the same script several times with different parameterizations. The third thing in a Spark job definition file is the environment. The environment, we talked already about Spark environments, gives you the capability to load specific libraries. And again, provide a dedicated Spark config for this environment. So you have a reuse there on the environment side, right? So you have essentially two areas where you can refine your Spark config. And last but not least, you have your schedule. There's a long line over here. So when we have like an overview, you have several components in your Spark definition file. You have the main definition file. This is your code. You have the parameters that gives you flexibility on your code. You have the environment that gives you a reuse set of libraries and Spark definitions that you can use for several Spark definition files or notebooks. And of course, you have last but not least, the schedule. So let's have a look how this works in practice. Okay, let's have a look how parameter flow works in the Spark job definitions. So at the beginning of everything, there is the user. The user passes the arguments to the Spark job definition, and the Spark job definition passes these arguments to Spark. And from Spark, in the end, it will go to a Lakehouse or warehouse. Let's say a Lakehouse, because it's Spark in this case. So when you draw like a line here, say, okay, the parameterization to the Spark job definition or in the Spark job definition is run with -- date equals, let's say, 2024 minus 0101. Then the Spark job definitions, a Spark job definition goes to Spark and says, okay, please start our session. Then Spark reads the parameters and processes the data to the Lakehouse, process data for 2024 0101. So this is where our parameter shines up again on the processing Spark against Lakehouse. Then data is returned. We are doing something with the data. We are most probably writing results. And we get the notice back, job complete, which goes back to the user as success. So this is like the walkthrough for the Spark job definition parameter handling. I've prepared the workspace in my favorite demo environment, and I will quickly show you what's around, right? So I have a Lakehouse, and I have imported a table called sales here, just simply for demonstration purposes. And I did the import with a data flow gen 2 that wrote directly to my Lakehouse. So it's currently loading, but I think that's fine. Let's go again to my workspace. There we go. And let's open the data flow, this one. So I can show you that there was a simple import. You see, that's the sales table. I did not do any modifications, and the data destination is my Lakehouse. So basically, that's it. And well, table is still loading. It was 140 megabytes, so not really small. So obviously it takes some time. This is like, oh, you see the data here. I think that's fine. So you get an idea, nothing special. So let's jump back to my workspace. And I have created a notebook. This notebook is not really used, but it illustrates the way from a notebook to a Spark job definition. So let's say we have a notebook that does some important stuff. In this case, we read the sales table, we read the top 1000 rows here, and we filter for the minimum revenue of 10K. So we apply that filter here, and then we display the filtered results, but only the top 10. So that might be even less because we pull only the top 1000 rows here. So let's start that. So it's running. We have 4 out of 4 Spark jobs, 8 in progress, 9 out of 9 succeeded, and we see the product ID here with this revenue larger than 10K. That works. So let's say this notebook, I want to transform this notebook, this Python code, and run it regularly. So of course I can run it like here. With run all, I can create a schedule. So I could add a schedule here, say, okay, every 15 minutes or every hour or daily or weekly, with a start and an end time and a time zone. That's possible. So I can schedule that. That's okay, but of course I most probably will have some overhead. I will have visualizations here inside of that code, well, in the end it's a different instrumentarium, right? And it doesn't really scale in a good way, and it's not pure code. So it's like a mixture. It's great for reporting, it's great for debugging, it's great for data exploration, but it has definitely a different target than just running Python code. How does the scheduled execution work? First and foremost, you need a schedule. So let's draw a schedule. So let's say, for example, every day at 3 a.m. So this is our schedule. Out of the schedule, there is the execution triggered. So this is execution. And the execution starts with the trigger of the Spark job definition. That's the first step. From that Spark job definition, then Spark is started. Start Spark. There you go. Spark then executes the job. Nothing that you wouldn't expect. And the results are saved. So this is the execution layer. And now the monitoring arrives. And this is the big difference against the notebooks. So you have a run history. And you can take action when the stuff fails. So for example, send an email if failed. This is the monitoring part. So you have the schedule, you have the execution, schedule, execution, and then the monitoring part. And this is one of the differentiator. So let's have a look how Spark job definitions compare against notebooks. So Spark job definitions versus notebook. There we go. So first, let's talk about the Spark job definition. Spark job definition starts with the job definition, of course, that you have already seen. Then creates a clean session. It runs pure code. And for the next run, you have a fresh state. This is the walkthrough for the Spark job definitions. Definition, clean session, pure code, fresh state. How does this compare to the notebook execution? So you have, instead of the Spark job definition, your notebook. The notebook runs in an interactive session. And you will get out most probably some visualizations. That you don't see because it's scheduled. You have a session state. Because the notebook uses that session, that means for the next run, you don't know whether you will get a new session or you retain the old one, so you have an unknown state. So this is the comparison from notebook versus Spark job definition. And the not so good part is basically over here. The not so good part is basically over here. Because you will start with an unknown state. The good part, that's the Spark job definition, is you will start with a fresh state. And you see, I think it's pretty obvious the differences: interactive versus clean session, pure code versus visualizations. So for production, you most probably will prefer Spark job definitions. So you want to do a Spark job definition because it's a cleaner separation from dev to prod. You have more and more professional ways of monitoring and resource allocation and so on. So first, you cannot use the notebook and simply run it as a Spark job definition. I have included a filter parameter, so I can show you that. And I have rewritten the code to work as a Python job definition. So let's bump that over. There you go. So you want to transform our notebook to a Spark job definition because you have a better line between development and production. You have better monitoring tools. You have better view on when is scheduled what and so on. So first point is you cannot simply just like execute or convert this notebook to a job definition. So you need to rewrite the code. In the age of artificial intelligence, that shouldn't be a big problem. So what I did is I rewrote the code. It's exactly the same code that does exactly the same stuff. So we can use it for our Spark job definition. and simply upload it. You need a file that you can upload, right? So let's go back to our workspace. There we go. And let's create a Spark job definition. This is the Spark job definition. There we go. And that's a very simple interface. We can upload our main definition file. I have pre-created that here. This is exactly the file that I've just shown to you. So this is my Python file. I can provide more reference files when I need them, and I can provide an argument here. And when we have a look to our code, then we have basically some arguments predefined. Excuse me. There we go. We have the minimum revenue defined. We have the table, the max rows to read, and the show rows. So we will pick the minimum revenue argument, and we can submit that here in the command line arguments. Minimum revenue equals 10,000. There we go. And we need to add our Lakehouse reference. This is the same Lakehouse that I just picked before. And basically that's it. Now we can save the whole thing. That's very fast, and we can run it. So now this job is submitted. It's a bit special that you always need to hit refresh. This will take some time, so let's speed it up. And last but not least, you can, of course, integrate Spark job definitions into pipelines. So you can integrate almost everything into pipelines. Let's draw that. You have your pipeline walkthrough. So pipeline is starting. And then let's say you do some ingestion with the data flow Gen 2. And after the ingestion, you do some transformation with your Spark job definition. And after that, you might do a copy job for archive. Copy. And after that, your pipeline has ended. This is your pipeline run from start to end. And you see the Spark job definition does a very good job in that scenario. So the job was successful, and we can click on the application name to get some more results. The job is just doing something, but not really producing something. It's just querying data. So we see the different job definitions here. This is the same like in the notebook. This is job 0 to 8, so 9 jobs. We can see the resources that were allocated. The executor core allocated by time. So duration was very small. We have logs here, which are really helpful. So you see all the stuff. So in this case, of course, everything worked. But when it didn't work, then you can get help here. We see our table, the same that we have seen in the notebook, is emitted here as the standard out. So that's pretty cool. We have the capability of doing snapshots here. With from the code, and we have a link to the Spark history server, which gives us access to the Spark environment here. We can download the event log and we can get more details or even more details on all the completed jobs, on the different events, the executor driver, the executor one was added, and all that stuff with the different stages. So for this job, obviously, it's a little bit too much of information. But still, when you have more complex jobs, this can be really, really helpful. We can see the environment. So the Java home, Java version, and so on. The different executors that worked on that, right? So 2 in this case, the driver and 1 executor node. So we can derive some performance from there, and we see the job graph, which is impressive for such a small job, but for more complex jobs, you will see and find that very helpful, of course. And we have also SQL and data frame output that we can use. So this is like a special UI where you can get even more information. When you have a long-running job, you could stop it here, and you can go to monitor and see, okay, how is the series? So when you run it every hour or something like that, you have the history and you can see what was happening there. So this is like a whole different chapter than just scheduling a notebook. Let's go through the community question. The community question number 1 is, hey, my scheduled notebook has random failures with state errors. What to do? So the answer is, this is number 1 reason to go with Spark job definition instead of scheduled notebooks, because notebooks keeps the state between runs. If you, for example, manually define a variable and the schedule run expected, sometimes it's there and sometimes it's not there. So the solution is a Spark job definition, fresh run every start, no data leakage, no state leakage, and reproducibility is really high. So next question is, hey, when should I go with Python files as a reference versus notebook references? So, well, I just created my first Spark job definition. Should I upload a Python script or should I reference my existing notebook? Depends on the use case. If you want to go with pure ETL, you should go with a Python file. If you need debugging, you should use a notebook reference. When you need team code review, you are might better off with a Python file because you can put that in Git and review it. When you need rapid iteration, so from dev to prod, then you might reference a notebook. But I think you can hear it between the lines. In general, it's better to go with a Python file. So when you take this really serious over time, you will most probably convert that to a Python file. Next question. Hey, I want to process my Spark job definition yesterday's data. How do I pass the date values dynamically? 2 approaches. First approach is you can use pipeline parameters. And in the pipeline parameters, you can use expressions to build that dynamically. Second option is you can calculate that at runtime in code. So when the code is executed, then the yesterday's date is calculated. Pipeline is better because the date is visible in the history. So if you have any issues, it's much easier to debug. Next question. Hey, my Spark job definition fails, but when I start my notebook manually, it works. Question is, hey, is the same environment attached, or is the environment attached that covers all your needs? Is the environment published? You cannot go with draft environments. Is it in the same workspace? So the Spark job definition and the environment needs to be in the same workspace. How do I get notified that my Spark job definition fails? How do I set up alerts? How does it work? You can wrap it in a pipeline. That's very good practice because you can wrap everything in a pipeline, so you have a clear approach. You can use workspace monitoring features for that if you want, or you can do a manual check. So I think it's pretty obvious. Wrap it in a pipeline. That's a good idea. Well, that's from the community side. I hope you enjoyed the video and you got an idea about the Spark job definitions, and you learned that it's a very useful feature that you should go with when you run your notebooks in production. And when you want to get notified when I release my next video, please click subscribe on my YouTube channel. Thanks for attending. See you next time.